All right. So the new stuff that we have to learn about naming ionic compounds is what we do with what we call multivalent metals. Okay? Some metals, if you look up in your periodic table, have more than one possible charge. Okay? We call those the multivalent metals. Okay? Those metals, when they're in a reaction, sometimes will lose 2 electrons, sometimes they'll lose 3 electrons. Okay? It all depends on what metal. All right? There's a problem with that, though. When it comes to naming, 2 different compounds could possibly end up with the same name. And that's not good, because what if one of them is good for you and the other is poisonous? Okay? And you're reading something that says, add iron oxide to this material, and you pick the one that's poisonous. Okay? That could be a problem, right? You have 2 things with the same name. Right? It's not going to work out, so we have to have a different way of identifying these compounds. We have to change their name somehow. So the example I'll give you here is if I have these 2 compounds, FeO and Fe2O3. Okay? Iron is a multivalent metal. In a reaction, it can lose either 2 electrons or 3 electrons. Okay, so as a result, when it bonds to oxygen, it could bond as it does in the first case or in the second case. Okay, those 2 compounds have very different physical and chemical properties because obviously they're different chemicals. Okay, but if I'm just naming them according to the rules we just learned, they would both be called what? Iron with oxygen would be iron oxide. Okay, that's a problem. Okay, that's like having 2 people in the same class with the same first and last name. It's happened to me once, actually. Okay. I once had 2 Chase Andersons. Same class. Yeah, weird. Really weird. 2 totally different people. Okay, and this is the same case. Okay, this is 2 totally different compounds, but they would end up with the same name. Right? So what we have to do is we have to alter their name by putting a Roman numeral in it that tells us the iron in this compound is the iron that has a charge of 2+, or this is the iron that has the charge of 3+. Okay? Now, how do we figure it out? That's the question. What's that? It says on the table, but if I'm looking at just a name, okay, like if I'm looking at iron 2 oxide, how do I know, or if I'm looking at a compound, how do I know it's iron 2 oxide versus iron 3 oxide? Okay. This is how I figure it out. If I'm looking at this compound here, okay, the charge on oxygen is always the same. What is it? -2. Okay. All ionic compounds have to have an overall charge of what? Of 0. Okay? All ionic compounds have to have an overall charge of 0. Okay? If I've got 2 negative charges on the oxygen, what's the charge on iron? 2. Okay, so then this stuff is iron, Roman numeral 2, oxide. Okay? The other type of iron oxide, this kind, okay, is going to be different. Okay? Again, what's always the charge on oxygen? -2. Okay, how many oxygens are there here? 3. So how many negative charges do I have in total? I have 6 negative charges, because every oxygen carries a charge of -2. Everybody okay with that? Okay, if there are 3 of them, then I have 6 negative charges. That means from these 2 iron atoms, I need to get how many positive charges? 6. Right? If I'm going to make this compound equal 0, I have to get 6 positive charges from these 2 irons. So each one of these irons has a charge of 3. Right? 3 times, positive 3 times 2 equals positive 6. 3 times -2 equals -6. Those add up to 0. So this is the iron that has the positive 3 charge. This would be iron, Roman numeral 3, oxide. Okay? It doesn't happen often, but there are certain metals that you can see on your periodic table that do carry more than one possible charge. Most of them are somewhere in the middle. Okay, so we're looking at things like manganese, chromium, okay, cobalt, iron, nickel, copper. Okay, those are the ones that we would use most commonly. Lead is another one that has more than one possible charge. Tin as well. Those are all fairly common. There's lots of others that also have more than one possible charge, but we rarely use them. Okay, the rules still apply the same way, okay, but we don't encounter them as often. Okay, so let's see if you guys can name this one. Okay, I'll give you a minute on that and then I'll walk you through how I would do it. Okay, so here's how I would walk through this. First thing I would do is I would name this like it's any other ionic compound. Okay, I'm going to write the name of the nonmetal, the name of the metal, then the name of the nonmetal, ending in I. Okay, that's how I'm going to start. So I'm just going to write that this is copper nitride. Okay, then I'm going to check and make sure my metal, or see if my metal, has more than one possible charge. Okay, does copper have more than one possible charge? Yes, it can be a 1 or a 2. Okay, so what I need to figure out is this the copper that's going to need a Roman numeral 1, or is this the copper that's going to need the Roman numeral 2? Okay, that's what I have to figure out using what we did with that compound before. All right, so what I look to help me with that is I always look at the nonmetal. Because if you look at your nonmetals on your periodic table, none of them have more than one possible charge. Okay, they're always going to have just whatever charge is written there. Nitrogen is always a -3. Okay, so every oxygen carries 3 negative charges, and I have how many oxygens here? Or sorry, nitrogens. I have how many nitrogens here? I have 2 nitrogens. Each one carries 3 negative charges for a total of how many negatives? -6. Okay. My compound has to equal 0. That means I have to get 6 positive charges out of the 3 copper atoms that I have. Okay? Positive 6 divided by 3 is? Is 2. All right, so this is the copper with the 2 plus charge. So then I just write 2 here. Okay? Basically, like finding like the common denominator for fractions is really all you're doing here. Okay? You're just doing a little bit of simple multiplication and division, okay, in order to figure out what Roman numeral goes on here. Do you have to do this with every ionic compound? No, because only ones that have these special metals are going to need you to do this. The rest of the time, you never write these things. Okay? They're not necessary unless it's a multivalent metal. Right? So the process is always going to be the same. Write out the ionic compound's name, as you normally would, and then check if your metal has more than one possible charge. If it does, then you're going to go back and you're going to do this little tiny bit of math. Okay? You're going to write the charge of the nonmetal and figure out how many negatives you have by multiplying that charge by the number of atoms. Then you'll transfer that over to the metal and divide it by the number of metal atoms. That'll give you the charge and thus the Roman numeral that you'll put in. Okay? Always those same steps. And I know right now you're looking at that and going, geez, that seems like a lot of work. Okay? But you'll be doing that in your head, okay, by tomorrow. Okay? Like really, it's just simple math. We just have to remember what order to do it in. Okay? All right. I'm going to have you guys try a couple of these. Okay? All right. So we've done number 1. So we'll just quickly walk through that one together, and then I'll have you guys try 2, 3, and 4 again. Right? So Fe stands for iron. Okay. O stands for oxygen. So this is going to be iron something oxide. Iron does have more than one possible charge. It can be a 2 or it can be a 3. Okay. I just need to figure out which one it is. All right. So I look at my oxygens. Oxygen is always a -2. -2 times 3 is -6. Okay. to make this compound equal 0, I have to get 6 positive charges from my 2 iron atoms. 6 divided by 2 is 3. So this is iron 3 oxide. Okay, works the same on all of them. All right, so I'll give you a few minutes to try 2, 3, and 4, and then we'll walk through those together. Okay, so for number 2, okay, I've got cobalt and sulfur. So the first thing I'm gonna do is write what the normal ionic name would be, cobalt sulfide. Okay, does cobalt have more than one possible charge? What can it be? Positive 2 or positive 3. Okay, so if I'm looking at my non-metal, sulfur, sulfur is always a -2. So what does cobalt have to be in this one? Positive 2, right? There's only one of each. They have to balance each other exactly. I get to do a lot less math with one like this. Okay, so this is cobalt 2 sulfide. Okay. All right, with number 3, okay, I've got manganese. Okay, and chlorine, so this will be manganese something chloride. What are the possible charges for manganese? 2 and 4. This one's most likely going to be 4. Okay, but we'll double check. What's the charge always on chlorine? -1. Okay, so that means I've got 4 negative charges there, right? So this is definitely the manganese with the 4+ charge. Okay, the Roman numeral for 4 is IV. Okay, if you don't know your Roman numerals, you haven't watched enough sequels. Okay, there's always sequels. Like watch Rocky. Okay, if you haven't watched Rocky, you should watch Rocky. It's a classic. Older than I am. Yeah. Okay, for number 4, okay, we've got copper and sulfur together. Okay, so this is going to be copper something sulfide. I think we did this one already. Okay. Sulfur is always a what? -2. So copper has to be a +2. So this is copper 2 sulfide. Okay. So you know your Roman numerals. Okay. That's 1, 2, 3, 4, 5. You shouldn't need more than that. Okay. But 6 is VI. It's 5 plus 1. This is 5 minus 1. It's 4. I don't know. That's why the Roman Empire died. The numbers didn't make sense? I don't know. Okay. All right. You guys can give the rest of these a try. See how you do. Okay, I'll give you a few minutes and then we'll go through them. Okay, so for number 5, we got SN, which stands for what? Tin, right? Okay. And TE stands for tellurium, so we're going to have tin something telluride. Okay, and tin can be 2 or 4, right? Okay, what's the charge on tellurium? -2. Okay, so tellurium's always a -2, and I have 2 of them here, so I have how many negative charges? 2 times -2 is -4. Okay, that means from this single tin atom, I have to get 4 positive charges, so this is tin 4 telluride. Okay. Questions on that one? For number 6, I've got mercury with astatine. Okay, so this is going to be mercury something astatide. Okay, charge on astatine is -1, right? Is that right? Yes, it is. Okay, -1. All right, so charge on astatine is -1, which gives me a total of 2 negative charges. So this must be the mercury with the 2+ charge. Okay, for number 7, I've got polonium with iodine, so it's going to be some polonium something iodide. Okay, iodine's always got a -1 charge, so there's 4 negatives here, so polonium must have a +4 charge. So it's polonium 4 iodide. Okay, number 8, SB stands for antimony. Okay, and it's with sulfur, so we'll have antimony something sulfide. Okay, sulfur is always a -2, and there's 3 sulfurs for a total of 6 negative charges. So I have to get 6 positive charges from the 2 antimonies. 6 divided by 2 is +3, so this is antimony 3 sulfide. Okay. All right, for number 9, I've got nickel and nitrogen together, so this will be nickel something nitride. Okay. Nitrogen is always a -3 charge. -3 times 2 is -6. So I've got to get 6 positives from the 3 nickel atoms that I have. 6 divided by 3 is +2. So this is nickel 2 nitride. Okay, and then for number 10, okay, we've got ruthenium with oxygen. So this will be ruthenium something oxide. Okay, charge on oxygen is always -2. Okay, so -2 times 2 is -4. So this ruthenium must have a +4 charge because there's only one of it.
It says on here that ruthenium can only have a +3 charge.
That must be the update to it. Okay, yeah, must be an update to it because ruthenium on here can be 3 or 4. But, okay, I'll go with that. Okay, they changed the periodic table system for this year. Weird. I don't know why they did that. Trying to mess with me. Okay. Everybody okay with the ones other than that one that I screwed up? Okay. Well, yeah, because, I mean, according to your periodic table, that's impossible. According to mine, it's possible, but not to yours. So we'll go with yours. Okay, that's fair. All right. Any other questions on the Roman numerals?